Hello. SDN and NFV are going to be key technologies, not just in the data center, but in the wider world. They're stepping stones towards an open cloud, an issue we'll be exploring later. And I'm with HP's Erik Papir, who's going to tell us something about that. Erik.
So we have been, as I would say, all in with SDN and really working hard on promoting SDN in the enterprise. So we've have a complete open ecosystem. So we have a software developers kit that's been out there. We have an app store to allow people to kind of the same way that you would go and buy stuff on your mobile phone, to be able to do that from an enterprise approach. And then lastly are all the partner applications that go along with that, along with the controller. So really all of that together is quite a wide open SDN ecosystem.
Among the groups working to open the cloud is the Cloud Ethernet Forum, or CEF. Here's the CEF's president, James Walker.
I think we're doing a lot of things to open up the cloud. The main thing is that we've seen really a big evolution in cloud services over the last year, 18 months. And that has come because the cloud operators, the large cloud operators, have started to offer private connectivity into their environments. So suddenly, cloud or public cloud services are no longer just something that's been done to support shadow IT or test and development environments. Suddenly this becomes something which is usable directly within the enterprise. So because of that change in the market, suddenly enterprises are saying, hey, I can use these public cloud services and I can integrate them directly into my data center core, directly into my applications and services. But it only makes sense for me to do that if I have some standardized way to interface those things together. I want to be able to dynamically draw down bandwidth. I want to be able to create virtual machines in a unified kind of way. And overwhelmingly, the research that we see says that enterprises are going to be using more than one public cloud operator. They're going to be using 2, they're going to be using 3. They're certainly not going to be writing separate interfaces for each one of those operators to interface with them, and then yet another one with their carrier. They might have more than one carrier, they might have more than one data center. It becomes a huge burden on them and very expensive to write all these interfaces. So by standardizing these interfaces, I think we lower the barrier to entry for enterprises embracing the cloud, but I think we also make it easier for software to be built over the top of it. We enable better reporting, better analytics to take place, and better security, because we're dealing with a standardized environment and not a whole bunch of code which might have been written on an individual basis by different groups of people and not held to the same level of standard. So I think that this enables new revenue opportunities, new market opportunities for new companies to emerge, to help in that space. But at its base, it is providing services that allow enterprises to really embrace cloud and make it part of their platform.
Security is always at the top of the agenda and has been one of the biggest advances so far. Steve Chappell of Wedge Networks explains.
At Wedge, when we really started looking into this, we decided there really needed to be SDN-S and NFV-S, adding the security piece, because when they originally conceived, they didn't actually have a security implementation to it. And so what Wedge looks at is when you're designing and building an SDN type network, what security precautions need to be taken, and how do you need to think about your security while you're designing these solutions. And also with the NFV, when you're starting to virtualize a lot of functions, where the security in the past would specifically address the hardware of those functions, you're now virtualizing them. You have to make sure that you have a virtualized security function to go along with it to match it.
SDN's biggest impact has been in the data center so far, but that's about to change, as Mark Showalter from Infinera explains.
It's really an exciting time in the WAN to look at what's happening, especially when you consider SDN and all the options that it provides for service providers. We're really seeing 2 main thrusts happen in the industry. One is a thrust where the vendors are building a controller and trying to offer the controller that also manages the equipment. The other model we're seeing is more of an open model, and it's the approach that Infinera is supporting, where service providers build their own controller, and they don't rely on an equipment provider to provide them software to manage their network. They develop their own software, and then they manage the network any way they want to. So, to me, the most exciting innovations have been watching service providers look at the possibility that SDN provides them looking at the toolkit they have and deciding, you know what, I'm going to build my own controller. I'm going to differentiate my network with my own software, and I'm not going to rely on some equipment provider to build that controller for me. I think that portends a great change for service providers as how they are going to differentiate themselves in the future and how they're going to adapt to the changing needs of the cloud.
But what's the outlook from the service provider's perspective? How will it affect their businesses?
So let me go for NFV, because I think our strategy is similar to the majority of the industry, and that's NFV offers a lot of low-hanging fruit. So what we've launched today, we have an offering Asterisk in the cloud. So you can have a full-blown soft switch running somewhere in the network at a different data center, different servers, white-labeled servers. You can even run that literally inside of a Juniper switch that supports NFV. So any NFV platform is going to be able to run Asterisk on the cloud. We can do the same thing with Sonos. So this is one of the big NFV services we offered, and this is a wholesale service. So it's available to other carriers, and both carriers and enterprise are able to create essentially a PBX in the cloud and spin it up anywhere that they want, inside a VM or inside a network element that supports NFV. Moving on to SDN, this is really, we're looking at SDN as a way to create service packages and service bundles so that we can do a service mashup of multi-layer connectivity services with compute and storage mixed into the whole offering and orchestrated and spun up in relatively real time for our customers. So what we're doing different, within the data center, we have a strategy similar to everyone else with SDN. And that's very well defined, well supported, there's a lot of players. But SDN in the WAN, when you want to have elastic connectivity services where you have elastic topologies, elastic QoS, elastic service definitions where you're shifting from E-line services to an ELAN to an E-tree, you're putting double-rooted E-trees that go to single-rooted, or you add more optical infrastructure to your transport for a service instance. This is where we don't have the infrastructure developed yet. There are not vendor solutions, multi-vendor solutions. Each of the players like Infinera, Cyan, and Ciena are creating solutions that work out of the box on their platforms, but to get it multi-vendor is much more challenging and involves a lot of integration work. So we see this as a way that we're going to be able to spin up elastic service components and tie them together on the fly to create new service bundles, new value for the customer, and new revenue for KVH.
To me, SDN is about two unique things. The first is orchestration of a network infrastructure. And from that regards, people have been doing SDN for many years. I can't think of a network now that's not orchestrated to some extent. Right? Where things get interesting with SDN is when we talk about the separation control plane and data plane, the standard SDN mantra on that, where we can now make decisions for not only what's directly connected to me, but how do I make a decision on a route that's 5, 6, 7 hops away, right? And being able to do that from a carrier perspective is more interesting to me than in a data center, right? SDN's been in the data center for a very long time. But it's closed market, it's short, latencies are 10 milliseconds at most. Where we bring SDN into the WAN environment, now we have to deal with latencies of 200, 300 milliseconds. And it raises some really difficult challenges on how we have that control plane that still can be responsive, figure out what's happening and make changes in real time when we have 300 milliseconds of latency at the front end of that. So SDN definitely needs to get into the WAN. It needs to go that direction. Customers want to be able to tie their applications directly into the network. Right? Not every application has the same network performance requirements, and being able to control the network on an application by application perspective is difficult if we don't introduce concepts similar to what we're seeing in the second definition of SDN into that definition of SDN as a separation control plane and data plane, right? NFV Maybe we did it backwards, but NFV couples nicely in with SDN. If I think of NFV as a virtualized appliance that I can drop in a network, if I have a virtual circuit or flow, if we're talking open flow, I can drag or I can create that virtual appliance and chain them together and drop them inside a flow in real time to create a solution for the customer that they can't create today. Right? They maybe need the firewall part at a time, and maybe they need the firewall all the time. But the intrusion detection, maybe they only want to turn it on during certain events, and they don't want to have it turned on during other times. Or being able to immediately add new circuits and add new paths through the network, which are very difficult to do in a traditional network environment today. So I would see SDN definitely growing beyond the data center. The WAN's the next logical choice in that, and growing outside of the data center environment. But the challenge is, and maybe Asia is unique, the challenge is we have to go from Australia all the way to US or all the way into Europe, where those latencies introduce some really difficult challenges in managing and building and deploying that network.
SDN NFV, I think, is going to bring some really exciting opportunities. We've always had to look at the network as a static environment. We've always had to look at investing in the maximum capacity as it pertains to what we thought the network would achieve. What SDN is allowing us to do is treat the network as being more fluid, as having more flexibility, and recognizing that as the behaviors of us as individuals are incredibly dynamic, that the network can start to optimize to that as well. We all know that when we go home at the end of a day that we're all logging on to our networks, accessing our applications, and we've always had to design the network to that peak type of utilization. This means that we can configure, reshape the network based on what's required at any given point of the day.
And what do the analysts think?
So I think SDN and NFV are very complementary to each other. There's some commentary that suggests they're not, but I absolutely think they are. And I also like the fact that NFV, if you look at it from that virtualization layer approach and the applications, it addresses that very, very well. And it also flows forward into the security aspect, which is another concern that many organizations have now as they move towards cloud and into the virtualized application space.
I think it's an essential step for network in general, whether you call it SDN, whether you call it NFV, you have to have these virtualized network functions because customers are moving towards a greater OpEx type model. They're trying to maintain currency with all the technologies. There are more and more requirements in a security standpoint, in a mobile device management type environment, and it's very, very hard to keep up and keep current. So if we want to deliver those sorts of capabilities to the enterprise customer, who are in a skill challenged model as well, then the more stuff we can put into the network so that it can maintain currency, so that it can maintain rich functionality, and it can adapt to changes in the overall network environment, the better. So I think it's an essential part of evolving the network and driving revenue to the carriers so that they can maintain those value-added services.
There's several things to look at. I mean, for a service provider standpoint, NFV, SDN makes building out those networks a lot cheaper, makes building out those networks a lot more agile, basically. So from a cost perspective, it is a very attractive proposition for the service provider. So two things can happen. It makes delivery of any WAN service a lot more cost-effective for the service provider. It allows them to build a lot more agile network, WAN, wide area network as well. And from a customer standpoint, will they benefit from a lower cost delivery? Eventually, yes. I think service providers will have no choice but to pass on that cost savings to the enterprise. And also, a lot of these newer so-called bandwidth on demand, bursting of networks and so on, NFV, SDN makes it a lot more easier for those service providers to create a network service that is more agile for the enterprise, basically, in a cloud world.
The industry clearly needs to collaborate to ensure open standards, as James Walker explains.
The risk is that you continue down the track that we already have, which is that Amazon, for example, has an API which is a good API. It is clearly documented, it's very simple, and so on. And I can say exactly the same thing about the completely mutually incompatible API which sits in front of the Azure environment. And I'm sure I'll be able to say exactly the same thing about Google and so on. But this is not a sustainable model. Certainly enterprises need to be able to communicate easily with these different organizations. And also, it is desirable, since most of these cloud operators are not themselves also network operators, they would like to talk to network operators, dynamically bring up bandwidth and so on. And from an enterprise's point of view, apart from having interfaces into the cloud operators, they might quite like the cloud operators to have interfaces between themselves for disaster recovery, for example, geographic resilience, and a variety of other things. So I think that what we are trying to do is make that whole process manageable, something that enterprises can actually contemplate doing. I was in a CIO conference a couple of days ago, and the biggest complaint that CIOs had is, why do I have to ask for more money year on year as I embrace this cloud thing? Surely the whole story was that I was going to reduce my costs. It doesn't make any sense. But those integration costs that they are having to take on to deal with all of these different environments is a nightmare, and it becomes a prevention for them entering the cloud.
The final word goes to a company renowned for its SDN leadership, HP.
SDN in the WAN, we see that as another key part of it. There's a lot of applications. Some of our partners are already developing to take advantage of some of the WAN SDN solutions that are out there. And I think also going forward, there's going to be even more opportunities for us to be able to deploy SDN applications, really leverage them in the WAN space. And so as far as SDN goes, really, the journey has begun, and we're off to the races.